We are going to crush out a few notes for 4.0, getting ready. So basically what's there is just example problems for you. So I'll do one that's not on your page, and then you guys can do a couple that are there, and then we'll move on. We might not do all of them because there's not enough time. So we'll start, and the first thing we need to know about is collecting like terms. So this is pretty straightforward. To collect like terms, you add the numerical coefficients, and then the variable part of the term does not change. So in a little example, we could do, this is, you have nowhere to write this. You can just watch, and we can do it orally. So if we're going to collect like terms, what are the like terms in this situation? All of them, right? Because they all have the same variable. Nobody has like x squared, nobody has xy. They're all just x's. So we have 4 x's and 2 x's and negative 5 x's. So what's my simplified term?
1x.
Just 1x, right? We would group these guys for 6x, and then minus 5 of those x's, you'd be left with just x.
Oh, x.
Let's try another one. 5y minus 3y plus y. Again, they're all like terms. So to group them, I just do the math on the numeric part of the term. Positive 5, negative 3, positive 1. What's my simplified term?
3y.
3y. The way I would do this is I'd say, okay, I have 5 plus 1. That's 6 minus 3. 3y. Good. Go ahead and try the first 3 in your book. Okay, the next thing that we're reviewing is distributive property. This was actually the last lesson of the previous unit. So if you haven't watched that video, go watch it. This is just a quick recap. Basically, the distributive property allows us to multiply a binomial by a constant. So here's our binomial, and we're multiplying it by a constant. In this example, we're going to be doing it twice. When we get good with the distributive property, it will actually allow us to multiply a binomial by another binomial, or a binomial by a trinomial, or 2 trinomials, or whatever combination. You can use the distributive property to take care of that. So in order to do this, basically what we're saying is this whole group needs to be multiplied by negative 2. So 3f needs to be multiplied by negative 2, and negative 5 needs to be multiplied by negative 2. So first, negative 2 times 3f. We take the number part, multiply them together. Negative 2 times 3 is negative 6. And we have negative 6f.
And then 10.
And here we have negative 2 times negative 5, which is positive 10. Okay?
Oh, and that's all you do?
That's all you do.
Wait, so if it's positive 10, don't you just write 10?
Yeah, but you have to have a plus sign.
Yeah.
Together.
Otherwise it would be negative 6f 10, and that would be...
Because you're using it as a minus.
Okay, I'm going to move on. You can ask that question in a second. Here, we're just doing the same thing twice. So this is a group that cannot be simplified. U minus 2 cannot be simplified any further. But we need to multiply it by 3. So we're actually going to have 3 u's and 3 negative 2's, right? 3 u's and 3 negative 2's. And your head is already going, oh, that's 3u minus 6. And now here, there's a couple different ways you can do it. We're going to keep the negative sign with the 4. And I'm going to multiply negative 4 times 2u and negative 4 times negative 7. So negative 4 times 2u is negative 8u. Negative 4 times negative 7 is positive 28. Now, what's the next step that we can do here?
You can collect the like terms.
Collect like terms. So, I have a 3u and a negative 8u. I have a constant negative 6 and positive 28. So 3u minus 8u is how many u's? Negative 5 u's. And what's the constant?
6 minus
Plus 22. Go ahead and try the 3 that are before you. It's always really helpful, guys. Draw these arrows. It helps remind you, oh, I have to do negative 2 times this piece and times this piece. And remember, the sign sticks with the term that follows it, okay? In the example for C, there's a minus that polynomial. So you've got a minus sign and a polynomial with two terms. Yep, there's an invisible 1 there. That means this negative sign gets distributed to this term and this term.
Sorry,
Okay?
Emily.
Go for it. Okay, the next thing in 4.0 getting ready that we need to be familiar with is geometric relationships. We've talked about each one of these before, and they're pretty straightforward. What do you think this first picture is showing us?
A triangle.
A triangle that has
Three angles.
3 angles, and what's true about those 3 angles?
They all add up to
same.
160.
They're cute.
180.
They're not the
They
same.
add up, they're not the same, and it doesn't matter if they're the same or different or
They're
whatever.
all add up to 180.
They add to one.
A plus B plus C equals
D.
180 degrees.
That's definitely
Okay? Go ahead and jot that on your line there. What is the next diagram showing us?
A
right angle.
So we have a right angle.
What's a right angle?
A right angle.
Little square.
Yeah, but the line here.
And what happens to that right angle?
It's 90.
It's getting cut not in half. It's just getting cut into 2 angles. Doesn't matter what those angles are. But if
No,
A
plus
plus
equals
B
90.
equals 90 degrees. And what type of angles are these?
One's a cube.
They're cute.
That's what I was getting at.
Okay, never mind.
We didn't.
We never learned
We
about
never learned
Yes,
Complement.
we did.
Sure did.
complementary angles.
I forgot
Complementary
about
angles
that.
add up to 90
Remember, like,
degrees.
when, like, somebody
Yes,
did
sir.
a big shape
I remember
and
that.
there was like a bunch of lines through it to find out what
I
it
remember
all
that.
add up to.
Yeah,
No.
it happened. Okay, here we go.
It's
Last,
different.
guys,
It
regroup,
disappeared.
regroup. Last diagram, what is it showing?
180.
Showing 180 degrees, and what's happening to that angle of 180 degrees?
It's
It's getting
split.
split some way, shape, or form. So A plus B equals
180.
180.
Degrees. Oh.
And A and B are called
Complementary.
No.
A
Supplementary.
knowledge.
Supplementary.
Yep.
supplementary angles.
He said those words like 4 times.
No,
Okay,
it did say-
you don't have any problems to do there. You just need to be familiar with those laws. I'm actually going to draw. I'll draw a couple for you to do in that space on page 3 at the bottom of page 3. Guys.
Supplementary.
At the bottom of page 3, I'm going to draw a couple examples for you to do. Okay? Yes, please. You can wait till I'm done if you want. A 40-degree angle at the top, 70-degree angle there, and then one called X and one called Y. You need to solve for X and Y using the notes above. Okay, so you should have been able to use this property of a triangle, that all the angles, the sum of interior angles is 180 degrees. So right here, we already have 40 plus 70 is 110 degrees. So X must be 180 minus 110. 70 degrees. Now, if we know X, we can use the property of supplementary angles in order to find out what Y is. So what's Y?
110.
Yeah, Y is also 180 minus X, which was 70. So Y is 110 degrees. Okay? Okay, we are on page 4, talking about the lowest common denominator. This is a super important one, particularly when adding and subtracting fractions or rational numbers, which happens all the time, and fractions are awesome. So get used to this. The lowest common denominator, what do we call that? Lowest common denominator, otherwise known as, we could just write the LCD for short, is the lowest common
Denominator.
multiple of, now is your word,
Denominator.
the denominators. It's the lowest common multiple of the denominators of 2 or more fractions. Okay? There are 2 different ways to find the lowest common denominator. We're going to use both strategies. You can use multiples or prime factors. We're going to explain what both of those mean as we go. Okay?
Is this where that tree thing comes in?
Yeah, you can use the tree. We're going to skip kind of that process and just go right into writing the prime factors. But yes, you can always use the factor tree in order to find out what the prime factors are. So we're going to find the lowest common denominator for 1/6 and 1/8. So we're looking at the denominators, 6 and 8, and we're trying to find the lowest common multiple of them. So our first strategy that we can use is multiples. So we're going to list the multiples. List the multiples. Add your notes as we go. We're going to list the multiples of 6, and we're going to list the multiples of 8. Well, multiples basically just means counting by 6 until you find one that matches. So if we count by 6, we start with 6. What's next? 12. 18. 24. Let's do one extra just because we don't know the answer. Now counting by 8, so we have 8, 16, 24. Oh, I have the lowest. Now I could keep going and I would find more multiples. For instance, they both share 48. 48 is a multiple of 6 and of 8. But
you don't have to list that here.
we want the lowest common multiple. If you can do it in your head, that's great. Don't do this step. Okay? So, the lowest LCD is 24. Okay? The next strategy is using prime factors. So, I guess find prime factors. And after we do that, I'll explain the next step after, but first step will be finding the prime factors. So, prime factors, a prime number is a number that's divisible only by itself and 1. So, for instance, the number 3. You can't divide the number 3 by anything except 3 and 1, so it's prime. The number 17. You can't divide that into any whole numbers except divide it by 1, which gives you 17, or divide it by 17, which gives you 1. It's a prime number. Does that make sense? The number 8 is not a prime number. You can split 8 into 2 times 4, or 2 times 2 times 2. Okay? Or 4 times 2. Make sense? Not prime. So we're going to split these numbers into their factors, and when we're done, the factors that we split it into are all going to be prime factors. So what's 2 factors I can multiply together to get 6?
Like 1 and 6.
1 and 6, okay?
3 and 2.
So that 1 and 6 won't count because 6 is not a prime factor. You could continue to divide 6. Okay, so it's 2 and 3. 2 cannot be divided into anything smaller. 3 cannot be divided into anything smaller. Think about it for 8. So we could do 2 times 4, but then 4 is still not a prime factor. But 4 can be split into 2 times 2. So we have 2 times 4, and 4 is 2 times 2. Now this is the prime factorization. It can have a whole string of factors. It doesn't have to be 2. In this case it's 3. But they're all prime numbers. There's no other way to get the prime factors of the number 8. It will always be 2 times 2 times 2. Always.
If the number is always already prime.
Then you're done. Then it's just 17. Or 1 times 17 if 17 was the number. Or 5, right? So that's exactly this. Once you get down to a prime number, you're done. 2, 2, 2, done. 2 times 3,
numbers
done.
always be like the same, like, instead of prime? Like the numbers will always be like 6 and 8 instead of 15 and 17? Because how do you find a common denominator?
You can still find a common denominator for 15 and 17, yep, but right now we're deciding how could we do that. So that's the next step, was what you're asking. So this is a little note for you. The LCD, the lowest common denominator, will have all the prime factors of each number. Okay, this is going to seem a little bit tricky at first. So what you're going to do is we're going to start with the factors of our first number. So by the way, we're still finding the lowest common denominator of these two numbers. We already know the answer is going to be 24. Okay, I'm just showing you how to get there a different way. So we're going to start with the 2 prime factors of the first number. So 2 times 3. And then we're going to look at our second number, and we're going to add any factors that aren't already included. So we already have 1 factor of 2. It's right there. Okay, we used it already. But we haven't accounted for these factors of 2. Okay? We have 1 factor of 2 that's already from 6 is already also in 8. So we don't need to rewrite this 2, but we still need both of these factors. So we have times 2 times 2. Okay? 2 times 3 is 6, times 2 is 12, times 2 is 24.
We can do any way we want of these 2 choices. So we don't have to do prime factoring, we can go with most of them.
Yeah, you could do either way, but in a lot of scenarios, so right now you're thinking, oh wow, this one was way easier, I don't even want to try to understand this. Poor choice. Because once you get into bigger, more challenging numbers, you're going to want to do this. So 15 and 17 is a good example. 15 and 17 doing this, it's going to take a long time of adding 15, 15, 15, 15, 30, 45, 60, 75. You know, it's going to take a long time before you get a match with 17. But if you do this, you can get it pretty much right away. It just takes a little bit of work breaking up the numbers, okay? And we'll do a couple of examples.
15's not even a.
It's not a prime number.
Also,
Right, but
you're missing a 2 there, aren't you?
No.
No,
you're
sir.
not.
so that's the explanation. I take both factors from the first number, and then I look and see what's missing from the second number. So I already have a factor of 2, I included it already, but I still need 2 more factors of 2. So I added those at the end. Okay, so if another way to think about it is like this, and actually this is what I prefer. If you write it like this, and you write it like this, then just right away say, okay, these guys share. So now I just have to write 2 once for them. So that's 2, and then I have to include everything else that's there.
Couldn't those other 2
Okay.
cancel to go to the one thing?
Nope, because remember this is 4. So if I only multiply it by 2, that's not really sufficient. Okay, every prime factor from each number has to be included. So these guys are 1 together, and then each of these is their own. Okay, I'm going to do this 15, 17 one. I'm only going to do it one way so that you can see it as we go. So let's say you had to add 1/15 plus 1/17. Well, in order to do that, you need a common denominator. So to do it this way, it would be a long list of multiples and a long list of multiples, and you'd be going 17 times 1, 17 times 2, 17 times 3, 17 times 4, 17 times 5, and seeing if you could get a match with the column above. It's not a good strategy. But watch what happens when we take the prime factorization of 15 and of 17. Well, the prime factorization of 15 is 3 times 5. Right? Prime factorization of 17, 1 times 17. The lowest common denominator will have all the prime factors of each number. 3 times 5 times 17. You could write times 1, but times 1 doesn't do anything. So really all you'd have to do is chuck this in your calculator and you'd get it. Right? 15 times 17, I think, is 255. Okay? That could be wrong. Somebody should double check that. But this strategy. Okay, go ahead and try 1, A, B, and C. You're just finding the lowest common denominator in those. So you can do it any strategy you want, finding the lowest common denominator. Then in step 2, you're actually using the lowest common denominator to add or subtract the rational numbers, to add or subtract the fractions. There are the answers to the bottom one, so you can double check.
And you don't have to.
Examples 1 and 2. Yeah, you always simplify at the end, so there's an example of that. 16 over 12. In this scenario, you could write it as a mixed number. I never do, because whenever you're reusing a number,
They always said that you always had to do it as a